What happens if I take fresh garlic and drip its juice directly onto thousands of living microorganisms from stagnant water? Some people call garlic nature's antibiotic. Today, we're going to test that claim live under a microscope. Let's take a look at their reaction. Right now, under this lens, there could be over 1,000 tiny organisms swimming around, spinning, hunting, just living their tiny lives. And in a few seconds, their whole world is about to change. Let's watch what happens. Okay, here's our water sample. I collected this from the same stagnant pond a few days ago. Stagnant water might look gross to us, but under a microscope, it's basically a tiny universe. Ponds like this are usually packed with all kinds of microorganisms. Some swim fast, some barely move. Some look like they're spinning in circles for no reason at all. I can't tell you exactly what species we're looking at. Without lab testing, we really can't be 100% sure. But look at that movement. That is life. Real, active, moving life. Now let's bring in the garlic. Fresh garlic contains a compound called allicin. It's not present in the clove until you crush it or chop it. Once garlic is damaged, an enzyme inside it gets released, and that enzyme reacts with another compound to create allicin almost instantly. That's actually why garlic has that sharp, strong smell the moment you cut into it. Allicin has been studied for its effects against certain microorganisms. So today, we're not just adding a random plant juice. We're adding something that science already knows is chemically active. Let's see what that looks like in real time. Here comes the drop, and there it is. The juice is spreading across the slide. Watch this closely. Watch it right now. Wait, did you see that? Something near the edge just twitched and stopped. Let's zoom in. Okay, this is intense. A few seconds ago, this whole area was full of movement. Now look. Some organisms have slowed down dramatically. Some look like they're struggling to stay in one piece. But over here, over on this side, we've still got a few holding on, swimming like nothing happened. Why would that be? Same rule as always with a microscope slide. It's not one uniform space. The garlic juice doesn't hit every organism with the exact same concentration at the exact same time. Some organisms are right where the drop landed. Some are farther away, in water that hasn't fully mixed with the juice yet. So we're basically watching a wave of change roll across this tiny world in real time, just like we saw with the kiwi. Except this time, it looks a lot more aggressive. Let's keep watching. Right here, this one is still moving. Barely. Almost like it's fighting to keep going. But over here, nothing. Completely still. That's the kind of contrast that makes this footage so intense to watch. Some organisms clinging to motion, others just stopping, fast. Now let's slow things down and actually talk about why this might be happening. And I want to be honest with you here, because I'm not going to pretend we know for certain. Without lab equipment, we can't run the exact tests that would give us a definitive answer. But there are a few likely explanations based on what we know about garlic. First, allicin itself. This compound has been studied for its activity against a range of microorganisms. It can interfere with certain proteins and processes inside a cell. That could easily explain a lot of what we're seeing right now. Second, acidity. Garlic juice isn't as acidic as something like kiwi, but it still shifts the pH of the water around these organisms. Many microorganisms are extremely sensitive to pH. Even a small shift can disrupt how their cells function. Third, osmotic stress. This is just a sciencey way of describing what happens when the balance of water and dissolved substances changes suddenly around a cell. Cells are very particular about that balance. When it shifts fast, it can put the cell under serious stress. And fourth, simple environmental change. Sometimes it's not one single dramatic cause, it's everything at once. New chemicals, new pressure, a completely different chemical environment, all hitting the slide in the same few seconds. That combination alone could be enough to shut a lot of this movement down. So which one of these is the real reason? Honestly, we can't say for sure just from watching under a microscope. That would require proper lab analysis. But watching this reaction happen live, it's honestly one of the most dramatic things I've filmed on this channel. Let's check back in on our slide. Whoa, look at this area now. A few minutes ago, this whole region was full of tiny swimmers weaving in and out of view. Now, it's almost completely silent. A handful of organisms are still twitching, still trying. Wait, did you catch that one right there? It just moved. Just barely. Like it's holding on by a thread. That's actually one of the wildest parts of doing experiments like this. It's rarely instant. It's rarely all or nothing. You get these little moments of resistance, tiny bursts of movement from organisms that are clearly under serious stress but haven't fully shut down yet. It's honestly kind of amazing, watching something so small put up a fight we can barely see with the naked eye. So here's where we are. Most of the movement across this slide has stopped. A few organisms near the edges, in areas where the garlic juice hasn't fully spread, are still going. And based on everything we just talked about, the allicin, the acidity, the osmotic stress, the sudden environmental shift, any one of those, or some combination of all of them, is likely responsible for what we're seeing. But here's the honest truth. This is a home experiment, not a lab study. We're observing, not diagnosing. If you want to know exactly which factor caused exactly what, that takes real laboratory testing, controlled conditions, and proper equipment. What we do have, though, is footage of something genuinely striking. A tiny, invisible world reacting in real time to something as ordinary as a clove of garlic from your kitchen. I think that's what keeps pulling me back into this kind of experiment. You don't need some crazy expensive lab to witness something incredible. You just need a microscope, some curiosity, and a willingness to ask a weird question like, what would happen if I did this? If you enjoyed watching this tiny world react in real time, make sure you subscribe. This is just the beginning. I've got a lot more microscope experiments coming, and after seeing what garlic just did, I honestly can't wait to test what's next. So stick around. The next drop might be even more intense than this one.